All right, welcome, and now we're going to talk about performing operations on complex numbers. And before we get into addition, subtraction, multiplication, division, we want to make sure that you guys understand the patterns when it comes to powers of I, because this is going to be important to know. So as we know already, I is equal to the square root of -1. I squared we saw was equal to 1, or excuse me, -1. Right? No, 1. Or excuse me, I'm sorry, I am -1. Okay? And then I cubed is what? Well, it's I squared. You could look at it as I squared times I, which is just going to be -I. And then I to the fourth, you could look at this as just I squared times I squared, which is just -1 squared, which is +1. And then here, I to the fifth, we can just look at that as I to the fourth times I, and since I to the fourth is 1, look at that, we go back to I, which is here. Okay? So we see a pattern here. So it goes -√1, right, or I, -1, -I, +1. So it goes I, -1, -I, 1, and it keeps going in that pattern. So we can use that pattern to our advantage when it comes to finding powers of I with large powers, negative or positive. And the reason is because we know every fourth one, right? Every fourth one gives us 1. Every fourth power gives us 1. So I to the first, second, third, fourth, right? So we just need to find the multiples of 4 when it comes to the powers, because we know every multiple of 4 is going to result in 1. So in this case here, all I have to do is find out, well, how many multiples of 4 go into 48? And in this case, it's 12, right? So there's no remainder, right? So this actually equals I to the fourth raised to the 12th power. So this would be equal to 1 raised to the 12th power, which is always 1. What about 23? Well, how many 4s go into 23? Okay, in this case here, we go into, well, let's do I to the fourth, right? So how many of those I to the 4s can we get? And in this case here, we've got 5. And then that leaves I to the third, right? Because 4 times 5 is 20, plus 3 is 23. So we've got 5 of these to the fourth, so that's going to equal 1 to the fifth times I to the third. And so this is just going to be I to the third, which is equal to what? I to the third is -I. And so that's our answer. So what about 50? Well, 50 is 48 plus 2. So this is going to be I to the fourth times 12, right, times I squared. And so this is going to be 1, right, so that'll give me 1 raised to the 12th power, which is just 1, times I squared, which equals what? -1. And finally, I to the -19 right? Even though we have a negative exponent, we can write this as I to the fourth times what? Times negative times negative 4, right? Times I to the negative third. Right? And so that's going to give us I to the negative third. But that's not the way we want to leave it. Because we want positive exponents, right? We don't want negative 3. We want a positive exponent. So why don't we do this? We could leave it here and then we'll have to deal with it, but we haven't gotten to that yet. So let's do this. Let's do 4 raised to the negative 5th power, which would be negative 20, right? This would give us negative 20, but we don't want negative 20, we want negative 19. So let's multiply by I here. So I to the 4th is 1. So 1 to the negative 5th power is still going to be 1, which is going to leave us an I, which is our final answer. And so that's how you deal with powers of I. You make sure you memorize the first 4. So I is I, right? We already know what I is defined as, but I squared is negative 1. I cubed is negative I, and I to the 4th is 1. So it always goes I, negative 1, negative I, 1. And that's the pattern.